Robots just learned how to fight, not with pre-programmed moves, but adaptive reflexes.
Balance, timing, reaction. And suddenly, the future looks different. Welcome back to NeuroWire Signal, where we decode the breakthroughs shaping the next era of intelligence and machines. If you want to stay ahead of the AI revolution, hit like and subscribe. It keeps this channel growing. Today's topic isn't science fiction, because Kung Fu robots aren't a stunt, they're a signal. The moment robotics crossed a new threshold. For decades, robotics development focused on precision and repetition. Industrial robots were strong, fast, and reliable, but rigid. They excelled in controlled environments like factories, where tasks were predictable and repeatable. But combat movement is different. Martial arts demand dynamic balance, real-time adaptation, spatial awareness, and micro-adjustments under unpredictable conditions. When robots begin demonstrating fluid martial movements, dodging, blocking, counterbalancing, it reveals something profound. It reveals control over complexity. And complexity is the barrier that has historically limited robotics. From scripted motion to learned reflexes. Traditional robotic systems operate on deterministic programming. Every motion is pre-calculated. Every movement follows a defined path. If something unexpected happens, the system stalls or recalculates slowly. Kung Fu robots operate differently. Instead of executing pre-scripted moves, they rely on reinforcement learning systems trained in simulation. These models learn balance, torque management, and momentum control through millions of virtual repetitions. When transferred to physical robots, the systems carry adaptive instincts rather than rigid instructions. That's the breakthrough. It's not about fighting, it's about fluidity. Balance is intelligence in motion. Standing upright is easy for humans because evolution optimized our nervous systems for it. For robots, dynamic balance is an engineering nightmare. Every shift in weight requires precise torque adjustments across multiple joints. Add rapid directional changes, kicks, blocks, and reactive dodging, and you introduce exponential complexity. Kung Fu robots demonstrate mastery of balance under stress. They compensate for pushes, they recover from slips, they adjust mid-motion. That capability translates directly into broader robotics applications. Warehouse robots navigating obstacles, rescue robots traversing rubble, humanoid assistants moving safely in crowded environments. Martial motion is just a training ground. The role of AI in physical mastery. Behind these robots are advanced AI models processing sensor data in real time. Cameras, gyroscopes, accelerometers, and force sensors feed continuous streams of information into neural networks. These networks don't think in language. They calculate trajectories, they predict force impacts, they anticipate instability before it occurs. When a robot blocks a strike or pivots to maintain balance, it's executing complex control algorithms optimized through reinforcement learning. And every successful recovery strengthens its internal model of physics. Why this isn't about combat. It's tempting to focus on the spectacle, robots performing martial arts, but the real story isn't combat capability, it's adaptability. A robot that can react to a sudden shove without collapsing can also respond to environmental unpredictability in disaster zones. A robot that can adjust mid-kick can adjust mid-step on uneven terrain. These are survival mechanics, and survival mechanics unlock autonomy in the physical world. Simulation, the invisible training ground. Training robots physically is expensive and risky. That's why simulation environments are critical. In virtual worlds, robots can fall millions of times without damage. They can test extreme conditions, unusual forces, and unexpected disruptions. When their performance stabilizes in simulation, engineers transfer the learned policies to physical hardware. The result is something remarkable. Robots that appear instinctive. But instinct is just compressed experience. The leap toward general physical intelligence.
Artificial intelligence in software has progressed rapidly.
But physical intelligence, the ability to operate effectively in real-world environments, has lagged. Kung Fu robots represent a narrowing of that gap. General physical intelligence requires understanding friction, inertia, weight distribution, and momentum in dynamic contexts. Martial movement forces robots to master all of those variables simultaneously, and once mastered, the skill generalizes. A robot that can spar can also carry fragile objects without dropping them. That's the hidden leap. Safety and ethical implications. Whenever robots demonstrate combat-like capabilities, concerns arise about weaponization. These concerns are valid. Physical autonomy carries ethical responsibility. However, the same technologies enabling reactive defense can enable enhanced safety. Robots capable of precise motion control are less likely to cause accidental harm in collaborative environments. Precision reduces risk. The ethical challenge lies not in the capability itself, but in its application, and applications are determined by human decision-making. Industrial impact. Industries beyond entertainment or research stand to benefit. Logistics centers often struggle with irregular terrain and unexpected obstacles. Construction environments are unpredictable. Healthcare facilities require careful navigation around vulnerable patients. Robots trained in dynamic movement can operate more safely and effectively in such spaces. The spectacle of martial arts training accelerates broader real-world deployment because dynamic motion mastery translates to resilience. The psychological shift.
There's another dimension here: perception.
When humans see robots performing fluid martial arts, it changes how we conceptualize machines. They no longer seem mechanical or stiff. They appear coordinated, responsive, almost alive. This shift influences public acceptance. As robots become more natural in movement, resistance to integration may decrease. People trust systems that move predictably and gracefully more than those that jitter or stall. Fluidity builds confidence, and confidence accelerates adoption. Human-robot collaboration. The future of robotics isn't about replacement, it's about collaboration. For robots to work alongside humans effectively, they must react safely to unexpected contact. Kung Fu training environments simulate sudden forces and dynamic interaction. That improves robots' ability to operate around people without causing harm. Reactive agility enhances cooperative safety. This is how robotics transitions from isolated industrial cells to shared environments. Hardware meets intelligence. No AI breakthrough matters without capable hardware. Advances in lightweight actuators, torque sensors, battery efficiency, and joint flexibility enable these dynamic movements. Software and hardware evolve together. Kung Fu robots are a convergence point. Advanced AI control layered onto increasingly capable mechanical design. That convergence is accelerating, and acceleration compounds. Economic implications.
As physical intelligence improves, labor markets will feel pressure.
Tasks requiring dexterity and balance may increasingly fall within robotic capability. This doesn't eliminate human value, but it redefines it. Humans will focus more on oversight, strategy, creativity, and ethical governance. Robots will handle physically demanding, repetitive, or hazardous tasks. The transition may be gradual, but it's inevitable. Are we closer to fully autonomous humanoids? Humanoid robots capable of dynamic martial arts movements suggest progress toward broader autonomy, but full general autonomy remains complex. Cognition, perception, and emotional intelligence still present challenges. However, physical mastery removes one major barrier. A robot that can move naturally can operate in human-designed spaces without requiring redesign. That compatibility accelerates deployment. The broader signal. Every technological revolution includes symbolic milestones. The first powered flight, the first moon landing, the first smartphone. Kung Fu robots may become a symbolic moment for robotics, not because they fight, but because they demonstrate fluid, adaptive motion once thought uniquely human. That symbolism matters. It reshapes expectations. What happens next? As training techniques improve and hardware evolves, we'll likely see robots mastering more complex physical tasks. Parkour, rescue simulations, sports training, and collaborative industrial operations may follow. The trajectory points toward greater autonomy in physical domains, and autonomy reshapes economies. Conclusion: movement is power. Kung Fu robots aren't just viral videos. They represent a deeper transformation in how machines interact with the physical world. Adaptive balance, reactive control, and fluid motion bring robots closer to human-like physical intelligence. When machines master movement, they unlock real-world autonomy, and autonomy changes everything. Robots just learn to move like fighters and think like learners. This isn't about combat, it's about capability. If you want deeper insights into AI and robotics revolution, like the video and subscribe to NeuroWire Signal, because the future won't stand still, and neither will the machines.